The global economy operates like a highly pressurized hydraulic system. Millions of moving parts, factories, cargo ships, and entire cities rely on a continuous, uninterrupted physical flow of fuel to keep running. At the center of that system is the Middle East. Every single day, tens of millions of barrels of crude oil are pumped out of the region and pushed outward into the global network. The primary destinations for this fuel are the massive industrial economies of Asia and Europe. They absorb this constant flow to power their manufacturing sectors, run their agricultural machinery, and fuel their international shipping fleets. Global economic stability relies entirely on how reliably that oil can physically move from its source to destination. The sheer volume of oil sitting underground is irrelevant if it cannot travel. To get from the Middle East to the rest of the world, almost all of that oil has to pass through the Strait of Hormuz. This strait is a narrow geographic waterway located between the Persian Gulf and the Gulf of Oman. This diagram illustrates the extreme physical constraint of that passage. We are looking at 20 million barrels of oil, roughly 20% of total global petroleum consumption, forcing its way through a channel that is only 33 kilometers wide at its narrowest point. Certain economies have massive asymmetric exposure to this specific coordinate. Nations like Japan, South Korea, and China rely on this exact stretch of water for up to 75% of their total crude supply. Compressing a fifth of global trade into a physical space you could drive across in 30 minutes creates a fragile vulnerability. It is the single most critical point of failure in the worldwide infrastructure grid. In February 2026, targeted military strikes hit regional energy infrastructure across the Gulf. These explosions physically halted the normal hydraulic flow of the region. Commercial markets reacted even faster than the military blockades. Marine insurance companies deployed an effective insurance weapon, spiking war risk premiums for vessels by up to 3,000% and making it financially impossible for fleets to sail through the area. This data visualization shows the immediate result of that commercial and physical gridlock. The pre-conflict volume of 20 million barrels drops to near zero transit, leaving over 16 million barrels of oil per day instantly trapped inside the Persian Gulf. Emergency bypass routes failed to provide relief. Critical overland alternatives were neutralized by direct strikes on the port of Fujairah, a major bunkering and storage hub in the UAE, and the Saudi East-West pipeline quickly reached its strict physical capacity limits. A localized military conflict instantly severed the arteries of international trade, forcing a total systemic seizure of the global energy grid. Losing 20% of daily global supply overnight triggered an immediate panic across international markets. This chart shows the extreme price reaction to that supply shock. Within days, the price of Brent crude and WTI, the two major benchmark classifications for global and U.S. oil prices, spiked vertically past $100 a barrel. Because fuel is required to move goods, those soaring energy costs immediately inflated the price of global shipping, the cost of factory manufacturing, and basic consumer staples. Energy is the base cost of modern civilization. Starving the grid of its primary fuel source creates an inescapable worldwide inflation shock. To fight the panic, nations belonging to the IEA, the International Energy Agency, which coordinates global energy policies, authorized a coordinated emergency release. They pledged over 400 million barrels from their strategic petroleum reserves, which are massive emergency stockpiles of crude oil maintained for extreme supply disruptions. Simultaneously, alternative producers in the Americas, including the US, Canada, and Brazil, began pumping at their absolute maximum capacity to fill the void. This bar chart illustrates the critical logistical bottleneck in that plan. Even with massive total reserves, strict daily extraction and delivery limits mean the replacement oil simply cannot enter the system fast enough to match the 16 million missing barrels. When we subtract the maximum daily flow of those strategic reserves and alternative production from the missing total, the final math is clear. The market remains short by 3 to 7 million barrels every single day. Strategic reserves can temporarily buy time to prevent a total collapse. They cannot solve a structural geographic deficit. A hydraulic system deprived of its main artery does not die completely. It is forced into a permanent, difficult rerouting process. Ships and suppliers shifted away from using one highly efficient, centralized choke point. Instead, they scattered into a fragmented network of much longer, slower maritime routes, navigating all the way around the southern tip of Africa. Drawing a new map carries permanent economic consequences. It enforces higher baseline transit costs, guarantees increased supply chain volatility, and constrains industrial output across Asia. The era of hyper-efficient global energy flow is over. The world is permanently rewired, bearing the long-term cost of its geographic vulnerability.